Hi Ken, how are you?
Hey Rob, how are you doing?
Good, thank you so far. So we're all set, I guess.
Yeah, I got the
So the plan is the following, as you've seen, I guess, through our messages. I'm going to talk only a little bit about the ancient view of ontologies. I thought, since we are talking about the past, present, and future kind of things.
Oh
So
yeah, that'd be perfect. Do you want to talk first?
yeah, that's what I'm doing. I'm just going to do a brief introduction and start, and then Gary is going to take over.
Okay.
So I'll share my slides, I guess, unless you want to do it. I sent you the latest set.
I think I have the latest set, but I think it'd be better if you
Yeah, that's right. Yeah.
do it. I'm setting up the session page. Here.
It's kind of interesting how well this Gemini, and Nano Banana generate these figures.
There's the session
Yeah.
page. And yeah, there are links for the slides in here. So why don't you try sharing?
Okay. Can you see something?
Yes, it's very good.
And then I go into the presentation mode, I guess. Can you share it? Is it continue
That's
to
not
share?
quite presentation mode.
It's in the presentation mode or not?
No,
What mode it is on?
because it's showing something on the side. It's much smaller than what you'd had
I think
before.
something is wrong because I think one of the problems that happens is, let me share again. It may be to do with my display, probably. The other thing I have to do is, I'm glad we started this because sometimes it happens. Now when I share here, so the minute I go into the
So that's
presentation
actually
mode, no, I
not
have to,
too bad.
pardon?
Oh, no, that's smaller.
No, I think same problem I guess we have right now. Ah, you know what I'll do? Let me see the displays. It probably it's to do with the display. Much time we have? About 10 minutes. Let me see if we can do system setting. Had this problem before. Now if
I guess we're all here.
hey, I'm having some problem with my uh,
Well,
okay, let me see if I do this thing, okay? Then I'm going to share this Microsoft PowerPoint, and then go to this. So what happens now? What are we seeing? Same problem, Ken?
same
Pardon?
same problem. Gary, do you see something different? It's kind of
I see
small.
two images. One is the main slide, and then a small slide on the right side.
Okay,
Evolution
yeah.
of
No,
AI.
then it's showing one.
I
It's
guess that's the next
unnecessarily.
slide.
No, the problem is it's showing the wrong display here. So I have to see what to do here. There's a solution to solve this problem.
Yeah, I want to check my display also because I showed a PowerPoint, and I think the PDF would be better and more controllable.
Okay, PowerPoint file. Now, for WebEx, it's not a problem. For Zoom, some reason, you know what I'll do? Oh, Gary, go
There's
ahead. You
my
want to do the stuff.
there's my slide. Is that readable?
Yeah. System settings. Okay.
That's definitely readable. It's not full screen, but
Okay,
it's
I'll stop sharing. Let the Ram handle his problem.
If I just disconnect this completely here. No.
By the way, Ken, I think Ram and I had discussed having him present first. Ram,
yes, I
okay.
just talked with him about that.
Yeah. And the other thing I noticed is that the overall 2026 summit doesn't have titles of talks. So that you go for the day and you find out the name of the talk.
Because
But
we
it
don't
would be
have names
useful.
of talks. I wish I could post them if I mean,
Yeah,
if
well,
I-
you have one for next week.
Oh, right. I should put that in. But beyond that, I don't have much.
Yeah, and of course
I'm
you
going to
had
try to
ours.
get it
You had
updated.
ours yesterday, but I don't think any of the others. For example, Pascal hasn't given me a title yet, but I assume I'll be able to get it next couple of days. By the way, I want to apologize. I have a bit of a cold, so it doesn't seem to be affecting my voice too much, but my head is not not in the best shape.
All right. So let me.
I'm just telling. Still, you have the same problem? I don't even see the other
Nope,
one.
seems to be the better.
I'm showing the slide right now.
Yeah, this is the one slide. That seems to work.
One slide, so it's working. Okay, so that's fine then. Because
I'm sharing.
pardon,
I'm sharing.
you're sharing mine. Okay, then I think.
Sharing your slides. So
Okay.
this is what it hopefully should look like. Um,
Yeah, that's what we should have been. But 1 minute, let me see what's the problem
if
here.
you could do it.
No, this I'm trying to disconnect this display. Now it's coming here. This one is going here. So disconnect this. Oh, then I disconnect this display completely here. Display is disconnected. And then I go to system settings. And then I look at displays. I should only have one studio display. Okay, I only have one now. Okay. And now if I do the PowerPoint slide, okay, what are we seeing now? You should see only one. Hello?
I'm not seeing anything.
Pardon?
No
I'm
sharing,
not
as far
seeing
as I can
anything.
tell.
I saw
Yeah,
something briefly a few
You're
minutes
not
ago.
sharing.
Right. Oh, I have to share. Sorry. I have to share. Okay, now let me see share.
Okay,
What are we seeing?
Oh,
I-
that's
Pretty good.
beautiful.
I
Let's
see
go.
Yeah, very good.
in view.
Excellent.
Okay, that's good then. We are in good shape. Okay, then I'll stop sharing. Now
Gary, do you want to try now?
Sure. When he stops, I did test it out before briefly. It seemed to work. He's showing a PowerPoint. Let's see. I'll share my PDF. How does that look?
It's still not full screen.
It's not full screen?
No,
It is on my side.
I mean, that's a full screen you have there, I guess. Just
it's yeah, but it's showing it within your browser. So you have all of the annotations around for a browser. It's okay. I mean, that would work. But
Yeah, I'm not sure what the best thing to do on that is. I hope that's good enough.
Not seeing anything right now, just your self photo.
Good morning. I'm just here to listen.
um, this is what it looks like if I share it.
That's greatly visible. Can see everything.
It's filling up the screen a lot better. Anyway, so Gary, why don't you try once more, see if you can get it.
Okay, I'll try once more. Let's see here. I don't think I was able to get anything looking any better.
Morning, everyone. Hello,
And I
Ken.
know the left and right side, but that's about as
Oh, can you hear
unless
me?
some,
This is John
yeah.
Sullivan. Okay, just
Can
want
hear
to
you,
check.
John.
Just want to check. Okay, goody.
Good,
Good
good.
morning, John.
Good morning. Glad to hear you got your microphone fixed.
Yeah.
So yeah, Ron, you will do it yourself, and I'll share the slides for Gary.
Okay, we need to start.
Start in just
Hand
a
it over
few
to me. I'll
minutes.
start the slides.
Right, I will begin with a brief introduction, and
I don't think I'll be able to see the chat and things like that if there is something someone has to interrupt me. Because I've taken my second display out since I can't figure out which display to use.
I'm also
What do you want us to do, Ram?
Now, if there is an issue, you have to tell me.
Okay.
Because I won't be able to see the chat
All right.
once I'm in a presentation mode.
Great topic. Thank you.
You're welcome.
so we are streaming live on YouTube.
Do you have
I
any
no
idea how many
who might
people are
be.
looking at the prior 2 sessions we have had
We've been getting
this year?
views. Um, I don't know what.
Corey, it's nice to see you. among others. Of course, everyone is welcome, but Corey, how are you?
I'm doing very well. Nice to see you and a
Yes.
lot of familiar faces here as well.
Sure, sure.
A lot of us have very relaxing backgrounds now.
That is an understatement.
I just checked and 2 people are on the live stream.
Oh, oh, so if we wait a couple of minutes, it looks like every second someone is joining, which is a welcome sign.
Yeah, we generally get the upper 20s for these so far these sessions.
Yes.
So this read AI is working out pretty good. Looks like it.
Hopefully, it'll help with our synthesis and communicate.
Well, Michael, how are you doing? And
Good, very good, very good. Really looking forward to the today's session.
yeah, it should be pretty nice. Okay, so I think we can start. We are recording and we're also live on YouTube. So welcome everyone. This is the Ontology Summit 2026. Ontologies past, present, future. Today is the 4th of March, 2026. And we will now march forth to the track on ontologies and AI. Today we have 2 very eminent speakers. Our first speaker will be Ram Sriram, who is currently the chief of the Software and Systems Division, Information Technology Laboratory at the National Institute of Standards and Technology. Ram is a longtime contributor to the Ontolog Forum and the Ontology Summit. He's a member of the Ontolog Board of Trustees. Our second speaker will be Gary Burcross. He's a cognitive psychologist with over 30 years of experience with ontological analysis growing out of his dissertation, Knowledge Representation for Discourse Understanding at SUNY Stony Brook. He has taught human learning and cognition and problem-solving courses at the University of Delaware, George Washington, and George Mason universities. He served as lead of the Spatial Ontology Community of Practice, and he's also a longtime contributor to the forum and the summit. and is a member of the Ontology Board of Trustees. So I will now turn it over to Ram, who
Thank
will
you,
be
Ken.
giving us this exciting talk, fascinating talk about the history, deep history of ontologies going back to ancient India.
Can everyone see the slides, Ken?
Yes, looks great.
Okay. Thank you again for giving me the opportunity to present a little bit historical perspective on ontologies. And what normally happens is that if you look at artificial intelligence as such in terms of the evolution, there are several phases. The prehistory, I call it, the beginnings, the early years. Then we have this notion of knowledge is power, and there ontologies played a big role. And there is something about early neural networks during the late 1980s when Jeff Hinton was at Carnegie Mellon, and then he went to and fro to San Diego. He was at a number of places. So, but then some of the early work he did was at Carnegie Mellon. Then we had the silent period where we had Deep Blue, the rise of the robotics, commercialization of AI technologies, and so on. Then you all observed the neural networks which came to the fore, which is the second wave or the second revolution one can call, and it's to do with deep learning. Now what we are seeing right now is what is known as the third wave or the revolution, which is the symbiosis of neural and knowledge networks. So this is also called neurosymbolic reasoning. And we have over the past ontology summits seen several talks on this neurosymbolic computing and how ontologies play a role. And finally, we have this notion of this conscious machine, which you don't know what's going to happen. And people are kind of working on it right now. So what I'm going to do is now talk a little bit about the prehistory. I call it the Paleolithic for whatever reason. And then you have this Neolithic, which is Hume, Russell, Turing, and a number of other philosophers came into talking about knowledge representation and schemes like that. But really, the whole thing got started with the Indian philosophers, which is not much talked in the Western world. So I thought I'll just give you a briefing on what the Indian philosophers thought about not anywhere between 600 BC to 1000 BC. We're not really sure about the numbers, but 600 BC seems to be a fairly good number. That's almost about 200 to 300 years before Aristotle. And Aristotle's logic is the one which is talked about quite a lot. Any case, so if you look at the taxonomy of the ancient Indian philosophy, we have two kinds. One is known as the Astika, the other one is known as Nastika. In the Astika is the orthodox school, which accepts the authority of the Vedas as divine revelation. But anyway, basically they follow Vedas. The Nastikas don't accept Vedas per se as such as the source of knowledge, and there are several philosophies underneath the Karavaka, Buddhism, and Jainism. On the Astika, we have about 6 major philosophies: the Nyaya, Vaisheshika, Samkhya, Yoga, Mimamsa, and Vedanta. These are the 6 main philosophies. Now, the issue is that if you look at it carefully, the whole, people kind of tie this with the Hindu religion, but really it's more of a philosophy rather than a religion. Religion came a little bit later, but everything is bound in philosophy. The philosophical people try to tell you what the underlying basis of existence and God and things like that are there later, but that's not the purpose here. The main two, in terms of the Astika, the thing that is the philosophies that are very important to us are the Nyaya and the Vaisheshika philosophies. So if you look on the Nyaya philosophy is a philosophy, I think it's a pioneer in knowledge representation, because they were trying to model the world and how we process the information there, which is inference. Nyaya really focused on the inference, as you can see, where on the left-hand side, you see this paramanas, which are the valid sources of knowledge acquisition. One way of doing that is perception, which is input from direct sensory data. The second one is anumana, which is actually the inference, or either knowledge-based inference or neural network inference, whatever it is, that's a logic engine. Then you have the upamana, which is the analogical reasoning or semantic mapping. And the fourth one is the Shabda, which is the one which we get from experts, the verbal testimony. And these are the inferences kind of things. And there are other things which are really which are really ontological in nature, is the data model. In the data model is the padarthas, which are the categories of predictability, as you saw on the left-hand side. And you can see and this basically evolved in the Vaisheshika philosophy, and now they combine both the Nyaya and Vaisheshika because really they're very similar in terms of, while Nyaya focuses on the inference and process, Vaisheshika focuses mostly on the padarthas, which are the categories of realities. So at this stage, what they did was, and then they had in the padarthas, we had this notion of the top level. When people talk about top level ontologies, they have the same thing where they have this notion of the substance, whatever, that is a top level object, and then you have attributes, which are the gunas. Then there are other things in there, which is the substance is the top level thing. Guna is the one which is the quality, and then you have the samanya, which is basically the general, the class. Which I'll talk about it a little bit on a comparison with the normal, with what we have in the current day ontological world. Then we have actions, kavya. I think there is some, in terms of the figure which was generated, the things are not really right on the left-hand side, but you can see that on the right-hand side, the actual padarthas, the right things are there on the right side. So, by the way, these things are generated by Gemini, so they kind of little bit, it took some liberties, okay, on the padarthas. It's made some mistakes. We need to correct it. I'll correct it and send the corrected slide set later on. Then we have the notion of samavaya, which is really part-whole relationship. They call it inerrance, but it's a part-whole relationship. So that is basically, the right-hand side shows you the categories, which are basically the things that we look in our ontologies. And the left-hand side looks at the inference part of it. Now, Aristotle uses this three-step syllogism, which is the Anumana in the ancient Indian philosophy. And they kind of look at it from a 5-step process rather than a single-step process as such, okay? So the 5-step process that they use in terms of the formal query and resolution, one thing is the pratingya, or they call it pratlina here for some reason, that's proposition. Again, there are some errors in this, in the way this Gemini created this thing. And that's actually pratigna. Pratigna is the proposition. So that is the first part. And basically the idea is that if you see some, let us say, if you see some smoke on a mountain, now the proposition is that the mountain is on fire. So you make a proposition that the mountain is on fire. And the second one is hetu, which provides the observational data or ground for the claim. Like, for example, you say the mountain has fire, maybe because there is smoke, because as an observer, you see a mountain and you see smoke. So now you came to a some kind of a proposition that the mountain has fire. Okay. So then the third one they do is this called Udaharana, which is an example or explanatory principle. And this kind of provides a general rule and then cites a verifiable example. And that's a kind of a knowledge, stored knowledge base, we can say. So the idea is that, you can have a rule, whenever there is a smoke, there is a fire. And one of the example is like, if you look into your kitchen, in the kitchen, when there is smoke, there is always a fire. So you can say, well, that's a generic rule. Whenever there is smoke, there is fire. Then you the third part is upanya, which is the application. And here you formally apply the general rule to the specific case in question. In this case, you can say the mountain has smoke that is invariably connected with this particular fire. So you make that connection, you apply whatever the concept you had before, and finally you come to a conclusion, which is the nigamana, is actual conclusion, where you say, yeah, the mountain is on fire. So this is the 5-step process you follow, as the three-step of Aristotelian, where you say if A implies B and B implies C, then A implies C, that kind of a thing, whereas here are 5 stages in there. So if you want to compare with the modern KR schemes, you can say the beige object, which is actually the dravya substance, which is similar to the individual class. And this Visheshisha, which is the particularity, it is basically the instance of the URI. Then you have Samanya, which is the universal, and that's a class, Isa, in the hierarchy. Guna is the quality of the attributes that you have in like in a owl, its data type property. Similarly, you have the inherence, which is the part-whole kind of relationship. And then you have this karma, which is part of that philosophy I talked about, the padarthas. And karma is really the action of the motion. If you're looking at an object-oriented system, like when you send a message to this particular object, the object reacts in a particular way, or it invokes a function, and that's what this karma is, action and motion, and it's actually the processor function. And they also introduce this new one more terminology called abhaya, which is absence, or the negation part of it. And that's pretty difficult in databases, but anyway, it's like a not a null kind of thing. So then we have the other part of philosophy, Indian philosophies, which is based on Nastika, which are the non-Vedic systems. They reject the Vedic authority. And the philosophies are Jainism, Buddhism, Ajvika, and Karvaka or Charvaka, depending on how you pronounce that. So these are, again, some philosophical things. Like, for example, this I talked about it long time ago in one of the ontology summits, where if you talk about the Jain philosophy is kind of interesting because it says like absolute knowledge could not properly be communicated using limited concepts. Okay, all claims should be seen as relative and provisional. So that means if you look at any object, there are multiple perspectives. Now, one of the things to do with the Indian philosophy is that for a particular truth, there are multiple perspectives. That's not a single perspective, as Aristotle kind of mentioned, but here you can have multiple perspectives. Like, for example, I can look at a tree and say there is some useful shade of shelter, one perspective. It could be good to climb, another perspective, useful timber, third perspective, it's a oak tree, fourth perspective, and so on and so forth. So each of the perspective is valid. It depends on the viewer as such. So that has to be, I think Jain philosophy talks about it quite a lot. So in any way, what happened is that, as you know, as we all know, we've been working on category theory. Here I make a comparison of the category theory and of all the ancient Indian philosophies. Okay, like for example, in the category theory, we have objects which are defined by morphisms, and that's very clearly defined in the Buddhist philosophy. Similarly, the functors, which is basically the in the Nyaya logic, which we talked about, and it's the truth-preserving mappings of structure from one domain to another. And then you have the topos theory, which is the Jain philosophy talks about, where we just mentioned before, which is the truth is dependent on the specific standpoint. And then you have the categorical theory, which is in the Vasisika's Padarthas, where we talked about the formal categories and ontological structures. Okay, so what I'm going to do is that I thought I'll give 10-minute talk, just a little bit extended. So I'm going to stop at this stage and give it over to Gary.
Thank you, Ram. Do you want to take a question or two in case there's something from the audience?
Yeah, I can take two, and if depending on which one, I think we also have my colleague Subramaniam, who is probably can answer them too.
Anyone, if you want to ask a question, you can raise your hand.
And Robbie has his hand up.
Robbie.
Yeah, one quick comment. Excellent. Thank you, Ram. You have taken it primarily. Hello. You have taken primarily from Vedas onwards, namely the content of Vedas is as derived in these 6 philosophies that you described very well. And I just wanted to tell that there is a prehistory version which has a lot of science in it. And I have written an article which I will share someday with this forum, where I do discover things like particle physics. As you mentioned, Kanad, similar to that, there have been other rishis who have contemplated on things like ontologies in Vedas themselves. and in terms of particles.
Yeah.
Up
So there's a
to
lot of stuff over
formation
there. I'm
of
just trying to synthesize a little bit here. Also, there's a good reference here. If you see on this particular slide, there's a guy named Ranganathan
Yes.
who developed this classification called colon classification.
Yes.
Anyone interested in that, there are several papers in there, and I think this guy has done a very good mapping on the ancient Indian views of knowledge representation into the modern systems.
Yes.
So this is a good reference, then people can look into it.
Till recently, most libraries adopted the Ranganathan classification.
Exactly.
But
It's
now
better than this Dewey system. So the guy did a great job on that.
thank you.
In
Thank
fact,
you.
I just want to say that several standards, especially in process engineering, use Ranganathan style classification, what is called faceted classification, to provide multiple perspectives as well. So it has gotten infused in some of the standards making processes where they are actually identifying objects and processes, where the idea of facets and Ranganathan's idea have been implemented, especially in ISO 81346 and so on.
Thank you.
Yeah, I think because Sab and I have been thinking about this for some time. So thanks, Sab, for joining in. Sudarshan, you have your hand up?
Yeah, just a quick thought. Most often, if you see in the philosophy, the examples and things that you showed, is it related to only the macroscopic ideas of what objects are, or we are talking at the level of atoms and things? Because that is where the disconnect happens. The theory of small versus theory of large. Do you see any deeper thinking in that in Upanishads and Vedas? Because they have something on those.
Yeah. So if you look at this thing here, when you go to this Vaisheshika thing, if you look at that, if you go down to rightmost kind of thing where you have this paramanu, that's actually the atom. So the atom is the one which they talk about. They try to explain this at the atomic level, okay, and then combine this at the macro level. I mean, there are some attempts. I don't know too much. You probably know about it. If you want, if you can throw some light on that.
I'm just I looked at that in terms of the Pramanu, which I think I missed it before. But the issue is this, how you perceive a macro level objects is different from what we cannot see.
Yeah, that's an interesting philosophical question too, because these guys at the time thought that that atoms are the smallest elements available, and then everything is combined by the atoms. And based on how these atoms are combined, your life then they try to explain that in terms of how each individual is made of these atoms and things like that, and what happens, and how the characteristics kind of go, and so on and so forth. So there's a whole lot of philosophy on that. And if people are interested, they should probably go to this Vaisheshika philosophy, which goes into much deeper things in there. So if you Google, you'll find out all about this in more detail. So that's a good question for Gemini to ask Sudarshan. Now we are running out of time, I guess, here.
I just make a quick remark. If you notice right from the beginning, this ontology is based on relationships and processes. Because you know that objects change their identity all the time. It is the processes and how those processes act on the objects is what is based on the notions of relationship, which is what Buddhism talks about, and all of these people talk about that as relationships and processes as the primary pieces that are stable.
So maybe I can start my presentation.
Relatively
we have some time for questions after my presentation also.
Yeah.
So I've tried to organize my presentation on the theme of the topic of AI and ontologies, past, present, and future. And actually, the slides hopefully will be able to introduce some of the topics that will be discussed later on in more detail in the track. On this first slide, I reuse a diagram we had from
Gary, do you want me to
10 years
take
ago.
over?
Hello?
Gary would
Yes?
like me to take over Um,
You want to present? If you
I'll-
want to present the
I'll,
slides,
I'll put the slides up.
sure. I'll stop sharing. You can put the slides up. Is it easier to see them?
Right, I'm going to share. This should be a little bigger.
Okay. Oh, okay. So as in this first slide, I've used a diagram here, which is sort of characterizing AI in terms of three things that are happening: learning, reasoning, and ontology. Is really the ontology part represents knowledge. And as I annotated the diagram, particularly we're often talking about computer representation. It's a representational thing. And then this knowledge representation stands in for semantics of various types: computer representation semantics, real world representations. Together, the three aspects try to cover the topic, as we have talked about in the past, of intelligent systems, being made up of a couple of components. Learn knowledge from data, in particular, which is modern machine learning is doing, but also perhaps experience, which systems up till now haven't really worked on very much, but we know it's very important for human intelligence, as well as reasoning, which is often discussed less. And all of these interconnections are complicated and are advancing very rapidly. At the very bottom of this diagram, you notice, for example, I make a little quote from one of our potential speakers later in the series, Ben Goetzel, who notes that knowledge representation is not very a fashionable concept in modern neural net-based Gen AIs, but it's very important for us. So if you move down to the next slide, that will show you essentially the outline of my talk. I note also the diagram on the right side sort of captures this comment that I made before about the absence of knowledge representation and even reasoning within lots of what is discussed as AI. So you have, as this diagram here starts with generative AI at the bottom, goes to machine learning, and it has AI at the top, but it sort of leaves out the whole topic of knowledge representation and reasoning, KRR, which is very important. Now, here's my topic outline is essentially organized largely by time. So first, I will cover a little bit of past summits and what we've said, particularly the last 9 summits, particularly the last 2, actually, in which we had some critiques of large language models 2 years ago. And I'm going to try to cover a little bit of what was said in some of those summits as a link to what's happening in the current environment. Part of that presence is the integration of Gen AI into knowledge engineering and knowledge graph development and tasks. In other words, it's a large help. We had talked before about how you can use automation to help build knowledge graphs and ontologies. And now we have a lot more help on that task. But there are limits. So I'll talk a little bit about some best practices, as well as what we know about how good they can be. Then I'll move to a longer section, which is sort of directed towards the future, which is on hybrids and how incorporating things like proper formal knowledge into some of these activities, symbolic learning, can actually improve systems. And there's a variety of types of hybrids in there. And I'll wind up introducing the 3 speakers we have planned, and a little bit of one slide on one of the speakers, our next speaker actually, on the role of meaningful explanations as an important aspect of our future. Okay, next slide is a repeat from my earlier presentation at the launch of the summit, which looked at the last 9 years of the summits. And you'll notice that back in 2017, we had a very explicit summit topic on AI, learning, reasoning, and ontologies. I was a co-lead of one of the tracks and included these 2 topics as part of that. One was using automation and machine learning to extract knowledge and improve ontologies, a topic which now has advanced quite a bit because of Gen AI, I think. And we also had Alexandra Ultimari from Bosch talking about from machines that learn to machines that know, the role of ontologies in machine learning, which is a very contemporary topic, I would say. Moving on a little bit from 2017, 2018, we had a summit on context, and part of that was that intentional context of agents is very important. That is to say, we get a little bit more cognitive thinking about AI, and that's very much what people are thinking about now, and I'll have a little bit to say about that. Explanations was the next topic. As I mentioned, that's an important aspect of one of our speakers, at least, maybe both of our next speakers. We had a summit in 2020 on knowledge graphs, and of course, a very hot topic at that time. And knowledge graphs provide a lot of data that can be used to train machine learning implementations, but now we can build knowledge graphs with the help of Gen AI in a more effective way. I have a little bit to say about 2021, which is on harmonization, which still remains an important topic. You can build a lot of little elements, but if you build silos, you have a problem. You have to bring these together. And again, Gen AI may help a bit in some of semi-automate some of that tasks. And of course, the last two summits are very important. I'll have more to say about the neurosymbolic techniques and conceptualization and formalizations. Okay, next slide. So this slide just notes that there has been some work on harmonization that will in turn support machine learning. This comes back to the 2021 Ontology Summit, where we noted that machine learning is starting to help develop large knowledge graphs, but these efforts are often independent. Different knowledge graphs get built and they aren't necessarily covering the same knowledge in the same way as other ones. And so the idea of harmonizing between these things, like having essentially open knowledge networks that interoperate, becomes a very important idea. And as part of our prior summit, we recognized that harmonization is partly made difficult by the fact that we have poor quality natural language definitions. And if you axiomize on poor definitions, then you get a problem. Turns out that Gen AI can help with a number of these things. Okay, next slide. Next slide just summarizes 4 aspects of success that we've had at the present time, going from scientific discovery for drugs, and we might have a speaker, Yolanda Gill, on that, to robotics, which I'll speak a little bit more about later on, because I think it's a very interesting area that combines not only data from the environment, but maybe experiences for learning. Then, of course, there's the important topic of reasoning, and John Sowa is thinking about having a track that may get some of these issues about improved reliable reasoning with symbolic knowledge bases, such as abductive reasoning. And finally, Pascal Hitzler may talk a little bit more about verification and validation methods to formally, essentially verify what neural nets are doing. Okay, next slide. So this is a bit of a summary from the 2024, 2 years ago, track where we had Gary Marcus and John Sowa.
Gary, just a little bit, I'm having problems seeing the slides. Is everyone okay?
Yeah, I can see the slides.
Okay, that's fine. There's some problem here.
We can see, maybe you can reduce the size.
That's okay. That's fine. Thank you.
I can see them pretty well
Okay.
myself, so I'm not aware of the problem. But if there's anything needs to be done, speak up. So this slide summarizes some of the major points that Gary and John made about critiquing where we might be going with large language models and their limitations. So Gary entitled his talk, "No AGI and No Trustworthy AI Without Neurosymbolic Aspects Included." And John's was "Without ontologies, the knowledge of ontologies, LLMs are clueless." And I'll just mention a few points, and I've included a little bit more than I'm going to talk about here. But for example, Gary emphasized the idea that we need rich cognitive models. We need extensive real-world knowledge. I have an arrow connecting those two because they're related. He talked about you need to have representations that include causal relationships. We need to have something aspect of common sense knowledge developed over time by embodied experience. That's what essentially cognitive robotics might give you, and so forth. And on John's side, talked about no fixed meanings, the challenge of meaning. Language is isolated from other cognitive things like perception, actions, and so forth, and we need mental models. Okay, so some limitations there. And indeed, if you go to the next slide, people are beginning to essentially try to move away from some of the narrow LLM approaches to include more richer things such as world models. And this slide just indicates that direction, noting something that Google is doing with a Jenny model, and NVIDIA is also developing its own. Now, these aren't necessarily the full rich models that John and Gary were talking about, but they include more spatial intelligence we need for, driverless cars and robotics and things of that nature. So that's a direction. My next slide, I'm not sure how many people have seen this. I just thought I'd throw this in. So we have a lot of critiques, but yet there are important developments happening and powerful tools out there. And so I took something from Dario Amodi, who has been in the news lately as CEO of Anthropic, and the way he has provided a thought about what might be coming and how we want to think about that, maybe the risk, because he's very risk oriented, as we know. So he says, imagine a world in the future, I said 2027 to 2028, and a new country with people where agents appears overnight. They have 50 million citizens, everyone smarter than any Nobel Prize winner who has ever lived. You can argue about that in this time frame. They think 10 to 100 times faster than a human, in a way. They never sleep. They can use the internet, control robots, direct experiments, and operate anything with a digital interface. What would a national security advisor in this situation say? And the answer is obvious. It's the greatest threat we ever have. So even though we might not be getting to AGI in this period of time, we might be getting to something that is powerful enough that we have to really consider some of these issues, even though we know there are many limitations. And indeed, the fact that there are limitations may be a big problem, because we may get things that are disruptive without understanding their nature. Okay, next slide. Next slide sort of ends my view of past ontologies and builds a direction towards the present and the future. This is the summary slide from Giancarlo Guazzati's talk about explanation, semantic, and ontology. And I think it very much sort of prepares us and gives us a context for thinking about where we are going, or where we think are some important issues. 7 points. All science is data science. Interoperability is fundamental for these sciences. No interoperability, however, without understanding. No real interoperability. No semantic operation. No understanding without explanations. 5, no explanation without semantics. 6, no semantics without ontology in the sense of these formal models that we build. And then 7 is no of these small ontologies without the big ontologies, such as Ram talked about in terms of the history, which is the philosophical point of view. And Giancarlo made a lot of points about that. So I would recommend people going back to his talk about that. Okay, so the next slide, and I'm more than halfway done here. So now, when we had our session on knowledge graphs, I had a session talking about how they're developed, and this very messy slide was talking about all the things and all the type of data you get to do it. And in the upper right corner, I had this little tiny thing, which is now marked more boldly, about Gen AI and machine learning as maybe an aid to what we were doing back 5 or 6, 7 years ago. Now it's a much more powerful tool for all of these things. It simplifies a lot of things. I'm going to have a few slides saying a little bit about how that's happening. So next slide. Because here I've taken sort of a very high level view of knowledge engineering in terms of 5 steps. And on the right-hand side, I've talked about some summary ideas about how Gen AIs help with some of those steps. They can help add text. They can go out there and get definitions and things like that and add it to a knowledge graph and an ontology. They can also identify major concepts, entities, and relationships within the domain and represent them in a logical form. And you have to have the proper prompts to do that, but a number of us have played around with that, and people have published on this. However, there are limitations. Without help, they have problems organizing the concepts and relationships into a meaningful structure. So that's a higher level task. That's still a challenge for some of them. They need help with expert review and iterative refinement. But you can essentially do that iterative works by a series of iterative prompts, and over time develop some best practices about how to query a Gen AI to actually help with something like that. So I have a little note at the bottom. Early work has showed that while many entities are extracted, they typically are isolated among connected ones, and the number of unique connections and word-based relators is just far too large. In other words, they don't come up with a primitive set of relations. You've got to tell them, use these relations and then form new relations based on these if you need to. So they need guidance on formal relationships. Next slide, please. So the next two slides sort of just show some of the things we know about this. This goes back a year or two, but the idea is that they can essentially, if you take some qualification steps about ontological modeling, they seem to do reasonably well in the 90s in terms of verification. And if you combine model answers with the axioms represented in different formalisms, it actually improves to high 90s. We do know that they are better at certain things like identifying incompleteness, things missing the axioms, compared to things like restriction reuse. And the article I'm citing is at the bottom. Next slide, again from this researcher, but this slightly different article. And for the sake of time, I won't go through these, but the point is that we are starting to develop some best practices. They're pretty obvious, like, we shouldn't have triples that contradict one another in there. They should be concise. They should be densely connected, which is the problem I talked about before. You have to find a way of prompting them to sort of consolidate things and things of that nature. But the important thing about that is we're starting to get some best practice on how to use this to develop things like a knowledge graph and or an ontology. Next slide. Okay, so the last two sections here. This section is on hybrid architectures. They're more cognitive, and as you see on the diagram on the left, they would combine a symbol system from earlier AIs as updated by modern work, and the essentially Gen AI connectionist neural net types of things to the side. And there's many ways of connecting them. You could use them one at a time, but then you get into various architectures by which they might communicate. So the simplest one is to have symbolic information, like speaking in a prompt, go in, it does something, and it comes out with symbolic information as a result. A very simple architecture. There are many such architectures. Kautz has identified several, but there are even more than he's identified. And of course, the coupling that we're looking at here could be through various interactive methods, including the calling of deep learning systems within a symbolic algorithm, or even the acquisition of symbolic rules during training of the connection system. The next slide gets a little bit at that. You can go to the next slide. These are the ones that Henry Kautz identified a number of years ago. The number one symbolic neural is what I talked about. It's the traditional one. You say words, it does something, it gives you back an answer in words. Number two is exemplified by the very successful AlphaGo I mentioned before, where symbolic techniques are used to invoke the neural techniques like a subroutine. Jumping down all the way to 5, for example, neurosymbolic uses a neural net that is generated from symbolic rules. That is the natural, a neural theorem prover, which constructs a neural network from and or proof tree generating from a knowledge base of rules and terms. Logic tension networks fall into this category, apparently. So the last thing I have on this, the bottom here, is that neural nets handle pattern identification and learning. That's their skill. And it's balanced by integrated symbolic reasoning, which might ensure organized decision-making and explainability, explicability. And, so proper symbolic reasoning. And so I have a reference here for other people who have talked about that type of balance. Next slide. I have about 3 or 4 more slides to go, and then we can have a conversation. This slide just makes the general case for adding ontologies to Gen AI, provides some from robustness. And of course, it provides things like understandability. We think it might provide more efficiency. And I have a little note. They're becoming more cognitive, but I have a note from Gary Marcus, who argues that we cannot construct rich cognitive models that are needed for this in an adequate automated way without triumvirate, 3 things that we need for such hybrid architectures, which is rich prior knowledge, which gets us into the ontologies, sophisticated techniques for reasoning. Next slide. Okay, so this is a little bit of a departure from what we've done in prior summits, but I find it interesting. There's a reference to something that I talked about back in 2008. I was part of the NIST PERMIS work for over 10 years. PERMIS stands for Performance Metrics for Intelligent Systems. So we were still early in the game, but we were talking about more bio-inspired designs, and that's what Janet talked about, for example, last week. And this is a diagram. It's a very simple three-part diagram on the right, which is the robot is embedded in the environment and acts on the environment, understands states of the environment, and gets rewards. So in a sense, the beginning of the idea of experience. On the left, I note that besides these processes going on, what's going on inside the robot has to, could be or should be, we think, becoming more cognitive, is that the agent is theorizing about states in the world, next steps, if I change something, and so forth. And so we have the rich mental models in here. Okay, so let me go to the next slide. And some of these ideas on robotic combinations of hybrids have starting to be developed. And this diagram going from the bottom to the top goes from very simple architectures to more complicated. As you see at the top has a much more complicated ones. So the ones at the bottom are traditional, where you do one or the other, or then you do one very simply linked to the other. And then the middle is where they're coupled in various ways. But the really interesting part is this upper A part, where it's called intertwined. And here the neural engine could learn something about predefined symbols in various ways, or it could actually discover symbolism itself by experimenting in the environment. And I think this is a very, given what Janet talked about last week, this represents a very interesting area for the future, where you actually, if you're combining these things, you're letting it build its own world model, and then you're trying to find out what exactly it does via things like explanations. So with that, my last two slides, and we'll have time for some discussion. So our next speaker is actually going to talk about some things like this, maybe not in the robotics realm, but Randy Goebel is in the Alberta Machine Intelligence Institute, and he's going to be talking about debugging foundational models as an eventual path to AGI, rather a stackable neurosymbolic framework. I have a slide after this which has a little bit on that. I've also invited Pascal Hitzler in the week after this, and he's well known for pioneering thoughts about this area of hybrids. And then Ram has invited Manis Gaur to speak on March 25th, and it's a working title. It's Neurosymbolic AI for high-stake applications in the LLM area, something of that in that realm. I do note down here that we hope, Ram and I hope, that some of the discussion of these speakers will help prepare for later tracks. I've mentioned the importance of interoperability. For example, our first speaker, Randy, is going to be talking about making foundational models interoperable, and I think Sean Sower is trying to organize a series of talks that will very much build on some of these issues. So my last slide, just showing you a little bit about what Randy will talk about from what I know and it's agreed upon topic and abstract. So he's talking about 4 foundational models going from left to right. Now we orient the ontological aspect with logical formalisms on the left, and we've been talking about hybrids with neural nets on the right. But also important and often missed in the discussion is the idea that we have probability-based foundational models. And now more recently, some success with reinforcement learning, like being able to AlphaGo, for example, learn about folding proteins. And the interesting thing is, how do we make these foundations communicate to each other and get explanations out of them so we're not confused when they are essentially being used in an intertwined fashion? And so there are many important issues here about efficient representations for particular tasks. And from Randy's point of view, he thinks it's very important that we have meaningful explanations as we go along with this, so we start to avoid some of the problems that were mentioned earlier in the earlier slide about a nation of agents, smart agents suddenly appearing, and we don't know exactly what they are doing and why. So I have backup slides, but that's for you to consume. And so I'd like to open it up for questions and answers and open discussion. Okay.
Gary, one thing I would like to mention, this is Ram here, is that on 25th, Louis Lamb also will be presenting. There are two people who will be presenting. It's in your email. I'm sorry, we missed it somehow. Okay, we need to update.
No, I was aware of the fact that we might have two, but I wasn't sure it had been confirmed. But
yeah, it's been
the more
confirmed.
the merrier.
Yeah, I'm sorry. My apologies. I should have checked with you on that.
That's okay. All right. So we have even better. We have two people on that March 11th or so. So is anybody raising their hand? Maybe, or maybe Ken and Ram have been reading the comments to know that there's something I should be aware of. I wasn't looking at that.
There are a lot of
Bobby has his hand up.
comments.
No surprise. Robbie's going to handle interoperability. I hope you can get some good speakers on some modern aspects of hybrid interoperability.
Yeah, with the good grace of my colleague Todd Schneider, we have one or two people lined up. I will be also speaking, and Michael Bennett is not here at this meeting, but he'll be speaking to us on one session. I will try to share my views on interoperability. And right now I have a question. The question is, while I'm thanking in the chat as well, John Sova and Pat Hayes for giving us a pre and post to ontology discussions. Pre is context is necessary, post is explanations. And you covered them both very well, Gary. So without much debate on that, the question I have is that this track is ontology and AI. So how do I view, as a layman, let's say, the ontologies in AI? Are they embedded? Are they discoverable? Are they distributed? Are they in multiple concatenated forms? What is our view of ontologies and AI together? That's my question. Anyone, including Gary?
Well, I guess I could say a few words. So hopefully we're speaking not only to the layman, but to people who are in the field, and we have many here who might be able to have a rich content. So my earlier talk at the launch talked about the semantic spectrum because we had semantic web, and I still believe that we have a variety of semantic resources that are important. But when you bring it down to the layman, I guess we are moving away from formal logic for that person to a more conversational type of understanding of things, and it's actually not visible to the regular user. So the big difference between a person in the field as a developer, a knowledge engineer, and a layman, I think, on this topic. And there's just a lot more that can be said. I see John Soa has his hand up now. John has a lot of things, I'm sure, to say, including maybe some information about his track that we should
Go
be
ahead,
aware
John.
of.
Yes, well, one thing that I really liked was Ram's view of several thousand years of the work in India and many different versions of ontologies and knowledge representations. And I think that is essential. And one of the things that I am very strongly opposed to is the idea that we can have a single perfect ontology. No such thing is possible. But we must have precise ontologies with formal logic for anything that is dealing with science and engineering. We can't do engineering without absolute precision. And for that, you must have the ability to take mapping from your ordinary natural language into the precision. And when we talk about ordinary people who have never studied logic really do know the subject that they're working on. You can go to pick anybody from any topic, from bridge building to running a locomotive to building a house, that when they talk about their own subject, they are very, very precise. They may not be using formal logic, but everything they're talking about their topic can be translated to and from logic with an ontology specialized for their subject matter. So this is something that we really have to consider, that formal representation is absolutely essential when you talk about science and engineering. You can't get away with some loosey-goosey kind of approximation.
Okay, I noticed that Janet had her hand up briefly. Oh, there it is again.
Can I read
Janet,
about
you're
it?
next.
Yes. I'm wondering, this idea of world models coming to the fore, how are people discussing whether that is the same as ontologies? Or, you know, it seems like it's Back to the Future, that, you know, it's similar but different. Or are they saying we realize now the importance of ontologies, just world models?
I don't myself think they're the same. The ontologies contribute to world models. World models have to be dynamic, so they had a lot of instances data. You know, what's happening with this car at this moment, or I'm on my way to deliver this package, and what do I do with it, and so forth. So ontologies provide some structure here, but the world model has a lot of instance dynamic data to it, I believe. So
okay, that's interesting. So in the slide from Pat Hayes and John McCarthy that I presented last week, they were talking about what AI needed in terms of a world model, and now you're adding that they're using it more as a world model that has dynamic instance data. So it's both an understanding of the world, of the structure of the world and the categories of the world, and how to...
But potentially, depending on the function, it has to also know something about people. So,
right.
In context, it was the idea of knowing something about intentions of other agents that are going on.
That's right.
Agents rather than people.
Right.
Now, I will note that we have both Deborah McGinnis and others here who might have more to say about this from direct experience. Mike Grininger spoke last week. He may have more to say about that. So I'd be interested in hearing what they might add. John, you have your hand up still. Is that another go at it? No. Okay. So I didn't know if Deborah.
Well, Gary, I guess just maybe a quick comment on your question. I think maybe Janet is right. I mean, I think we might have to just be clear on some of the terminology, because this might go back to the way back in prehistory about the distinction between ontologies and knowledge bases, right? Which eventually became the T-box, A-box combination kind of idea. And I think maybe some people, when they hear the phrase world model in the context of neurosymbolic, I think some think of it as being the ontologies, / T-box, and others, I think maybe based on your comments, think of, no, it's the ontology and the knowledge base. It's the T-box and the A-box that constitute the world model. But I think definitely when people are talking about world model in the context of foundational models, I think to me, that's one of the intersections between the neuro and the symbolic communities.
Yeah, I have a quick question. Oh, okay.
Deborah,
Deborah
McGinnis.
Thanks. Yeah, I think it's more common to think about it with the T-box and the A-box, and these days also an A-box might have some uncertainty in it, not just black and white 0-1 probabilities associated with it. And in that context, I think the ontology plus the A-box aligns with what I heard John say of the precision, but the things that world models are doing are not as precise. So I think that bringing in the uncertainty angle is more important these days. And certainly we're seeing more and more knowledge graphs be probability aware or uncertainty aware. as well as provenance aware. And I think that's part of our future. And if we don't put it as part of our future, other people are going to eat our lunch.
Uncertainty is inherent in nature. John?
Or certainly in measurement.
Okay, I just have one quick question, and I think Ram's survey of Indian logic and philosophy was immense, and to try to give any kind of approximation, summary of that in a short time is impossible. But I would like to see more about his slides and all that. Is there, does Ram have some references or some larger source of knowledge that we could look at that goes into that in more detail?
Has that been published somewhere? This is Cora, so excuse me for cutting in. No, I'm a classicist, and I'm interested in this background of comparisons with other philosophies, with Aristotle, with going back to these other ways of thinking. So I wondered if Ram has published this somewhere.
Okay. Yeah. To answer that for both of you is that I really, going back into history, I first made this presentation in 1992, okay, at IIT Kanpur. So after that, I never thought about it and just put it on the back burner until I decided to talk about it now. So I've not really written anything about it, but there's a lot of stuff which you can find. Let me see. And one of the things, actually, the chatbots are pretty good at giving this thing now. And also, there is a comment here by Sab, who's also been thinking about it. And in fact, he's writing a paper on Jaina logic and design. So if people are interested, he could potentially send you preview copies of it, Sab. But there's a lot of literature on this. And I get all my information from the books I study about Indian philosophy. Okay. So that's where my knowledge comes from.
Well, could you please?
I can give you some references, John Sova, on the books that I read.
Well, write them up in a nice.
Very helpful.
Right, write them up in a nice little note and send the note to Ontolog Forum, and I'll give a copy to Cora.
Okay, we'll do that.
Thank you very much.
Wonderful. I just might add one small.
Ravi,
small
please.
note.
Yeah.
One small note.
We have some questions in the chat that we need to handle. Jake, you have a number of comments in the chat. Jake? You still here?
Jackie has this very interesting comment on the slides which Gemini generated. So Gemini generated. And there's a reason for that, Jackie. So offline I can talk.
We are in the process intelligence. This is Mahesh Saladi. And we are trying to introduce to add ontology to our process intelligence. But our process intelligence is real time and ontology is always falling behind. How do we really catch up and make it liquid, like make it equal to what is happening today in the business processes, which are changing almost every day?
Thanks. Okay, Jake?
Yeah, sorry, it just occurred to me while Gary was talking, and he mentioned some of the large model generation of spatial worlds. I was wondering if there was if you thought there was a current link back to LambdaMu. If you remember, Pavel Curtis's one started at Xerox in 1990, which was an object-oriented programmable world. Throughout the 90s, there was quite a lot of research on that. I've talked to a few people about it before, but I'm just wondering if you see a connection back to Lambda, if you're familiar with it.
I wasn't thinking of that in particular, and I'm less familiar with it. It's been perhaps too long, but I think there is actually within the 80s and 90s, going back at least that far, maybe even farther. There's lots of thought about world models or discussion about it. But again, we say we didn't have the computing power and the storage and so forth that we later had to handle things like knowledge graphs. So there's just a lot more reasonable ability to handle some of the complexity that is involved in a world model.
Thank you for that.
And also, Mahesh talked about this processes dynamically changing. I think that's an important topic, and there's some research going on in that area. Definitely, I think Michael, you used to talk about process specification language, if you remember, when you were at NIST. So there's this whole notion of dynamic processes. That processes are constantly changing in the business world. That is, you develop a process ontology at a time interval X, and at a time interval X2, it'll be a different process ontology. So how do you handle those things, I guess, is the question, which Mahesh has pointed.
Yeah, I think, again, that's kind of a distinction that it kind of rises between the ontology and how it gets used. So one of my PhD students is looking at, Riley Moore is looking at the distinction between the process ontology, which captures a lot of the fundamental notions of what is an activity and the recurrences, et cetera, from the data theory, which is maybe a generalization of the ABOX. And that's where you would have, say, specific business processes that can change. Their description changes. The underlying semantics of an activity occurrence can never end before it begins. Like a sub-activity always occurs during the activity, not the other way around. Those are fundamental common sense notions of activities and their occurrences that hold across all particular processes. It's the data theories that change. It's kind of a generalization, again, of the ABOX.
Right. Okay, the next person who was in the chat is Phil. Phil Jackson.
Hello, can you hear me?
Yes.
Well, I think I asked a question, which is whether these differences in ontologies that have been discussed would imply that we should have a meta-ontology or an ontology of ontologies. And Janet Singer gave an answer that she indicates she thinks so.
EJ Lakshmi ready, or one other.
So anyway, that was the topic that I was asking about, and that's a pretty large topic, and maybe there's too much for us to talk about now. But anyway, it's a concept.
Right, and I think the slide on category theory and how useful it can be in spanning deep differences in assumptions. Well, that's what category theory was developed for. That actually is promising. I think because I think one sort of has a challenge here with the set theoretic worldview that takes knowledge representation as being stable and straightforward, and that was more the left-hand side of Rom's diagram, and then the heterodox views were more category theoretic, and maybe with DOL and progress in challenging the idea that representation is one kind of thing, having a meta-representational view or something like that. Maybe Ken's work will come back into this anyway, I think it's promising. It's a big challenge, but it does have to get at some of the deeper issues of what it means to represent for a machine.
So I would just quickly add that I tend to think of foundational ontologies as this meta-ontology, and last year we had Giancarlo speak a little bit about some of the things that might go into that. So you might go back to take a look at his presentation and publications on foundational ontologies.
Okay, last, I'd like to ask Todd if he wishes to speak. You did post something in the chat. Todd, you still here? Yeah.
Yes, I'm here, Kenneth, but no, I don't have any questions to ask. Thank you.
Okay. And then Ravi, you had your hand up for a while.
Well, thank you, Ken. I had only two comments. The meta object facility of OMG has BPMN for business process modeling, but there is no T dependence as far as I know, as of the time we developed BPMN. It was also related to the resource description framework, and the joining two was called ODM. Ontology Development Meta Model. So there is a merit in what Phil Jackson raised as a question. And just as in the earth science data, familiar to most of us, there is a metadata about the repository. Similarly, there might be a merit, and certainly in old Indian philosophy, there is a meta ontology, but in normal IT usage, we have a case for meta-ontology. Whether it's the same as foundational or upper is something I cannot comment right now. Thank you.
Okay, with that, I think we've covered everything in the chat. And unless there are further comments or questions, I think it's time that we adjourn and look forward to next week. And Gary has already given.
Yeah, next week is Randy Goebel will be talking about foundational models and the interoperability between them and the role of explanation in building such a hybrid.
Great. Thanks to everyone, especially to Ram and Gary, and looking forward to seeing all of you next week. And with that,
great session. Thank you.
It's a great session.
Bye all.
Bye.
Bye.
Thanks for all the symbolism.